Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Algebra 1 Common Core Regents Problem 13. If you want to access these exams from anywhere in the world, go to nysedregents.org, click on the appropriate tabs, and all the past tests are freely available there. Here's the problem. The height of the rocket at selected times is shown in the table below. Now, when I look at a table, I just look at the headings, time, and height, and I look at the numbers from 0 to 7 seconds, and I look at the height from 180. It looks like it's going up, and then it looks like it's going back down, and I don't analyze the table much beyond that before I keep reading. So, based on these data, which statement is not a valid conclusion? The rocket was launched from a height of 180 feet. The maximum height of the rocket occurred 3 seconds after launch. The rocket was in the air approximately 6 seconds before hitting the ground, or the rocket was above 300 feet for approximately 2 seconds. Now, how to do this problem? One of the things I've noticed recently is that a lot of kids don't even bother drawing a diagram for this kind of situation. So here's the ground, okay? Here's the ground. There we go. That's a horizontal line. Now, it says at height times 0, it's at a height of 180 feet. That answers a lot of the questions that it could possibly ask already. Height 1, wherever 180 is, it's somewhere. So I put it there. Height at time 1 is at 260. At time 2, it's at 308, not quite as high. At time 3, it's at 324. Okay? And then at time 4, it's at 308. I notice it's the same as time 2, so I carefully draw it next to the same place. Time 5, it's at 260. And at time 6, it's at 180. And then at time 7, let me draw that a little bit more horizontal. And then at time 7, it's at 68. The rocket is at 68. That answers so many questions on this thing. That's actually what I recommend that you do during the test. Even if you don't know how to do this problem, why not draw that diagram? It answers so many questions. So, choice 1, the rocket was launched from a height of 180 feet. And we're looking for a not valid conclusion, right? So, not launched at, not true. Was it launched at a height of 180? No, it was launched at a height of 180. That's right there. So this is false. This is true. Therefore, we're looking for false. So this is false, not the answer. The maximum height of the rocket occurred 3 seconds after launch. You look at 3 seconds, 324. And we look up to the left and to the right, 308 and 308. Those are the same. So that means that the max height was at 2 seconds. So that's a valid conclusion. That's true. So that's not the answer. The rocket was in the air approximately 6 seconds before hitting the ground. Well, we do see just from the picture and from the data that 7 seconds later it was still dropping. So that's definitely false. So this looks like it's going to be the answer. I'm going to put a star there. And then the rocket was above 300 feet for approximately 2 seconds. Well, at time 2 it was at 308. At time 3, it was at 324. At time 4, it was at 308. So between time 2 and 4 seconds, this is a 2-second interval, it was above 300 feet. And in fact, for a tiny amount of time before 2 seconds and a tiny amount after 4 seconds, it was still above 300 feet. So they said approximately 2 seconds. This is true, therefore not the answer. So it is, in fact, choice 3. Okay, here's a similar problem. With the same data created by us. The height of a rocket at selected times is shown in the table below the same data. Based on these data, which statement is not a valid conclusion? So it's a new set of conclusions which may or may not be valid. At this point, you should definitely pause the video. Try the problem on your own, and when you're finished, press play to see our solution. By the way we're able to provide these tutorials totally free is by having viewers like you see these problems. So if you like what you see, click the like button, subscribe. We have more videos coming. So let your friends know that these videos are available also. We have videos in algebra, geometry, algebra 2, trig, biochem, and physics. So definitely look out for those. More than that even coming soon. So again, which is not a valid conclusion. The rocket, let's see, flew for over 7 seconds. It did. Over 7 seconds. It flew for 7 seconds, and it still has a little ways to go before it finishes its fall. So this is actually a true statement. So that's not the answer. The rocket flew horizontally for part of its flight. Uh, well, why? This is a height. There is no data at all on the horizontal flight, so this is questionable. It can, in other words, it cannot be made as a conclusion. So this is probably the answer. Let's see number 3. The rocket was launched at a higher elevation than where it landed. Wherever it happened to land, it started at 180. It went down to 68. 68 is lower than 180, and it's going probably even lower. So it's not. This is true, and that's not the answer. Therefore, and the speed of the rocket is dependent on time, meaning the speed at which the rocket goes changes over time. Well, the rocket went from 180 to 260. That's a height. That's a height change of 80 in 1 second. So the average speed between time 0 and time 1 is 80 feet per second. The height from time 2 to 1 to time 2 changed from 260 to 308. That's a height of change of 48 in a time span of 1 second. So that's 48 feet per second on average. That's different changes. So it definitely changed over time. So this is not the answer. So in fact, choice 2 is the answer. I hope you got that. I know you could do it. Keep working at it. Thanks for watching. Stay tuned for the next video starting right now.